Hi, I am Miguel Castillo and I'll show you how I use this multimeter, the Multicom Pro MP730679, to validate a small Arduino-based embedded system. In this case, there are three topics involved: the transducer principle, how can I convert one kind of physical phenomena in other. In this case, how can I measure current when only the ADC can handle voltage signals. The other one is the power management. With a PWM signal, how can I handle the power in a load like a motor, like a lamp, and so on. And finally, the signal conditioning involves a small signal voltages. So we require mainly in shunt resistors a differential amplifier. So how can the variance in the element, in this case the resistors, modifies the behavior of this amplifier? Finally, some interesting functionalities in this multimeter is the measure of the frequency and duty cycle, the load resistance, and other interesting things. So let's do it. I'll show you the small setup. In the right side, we have the multimeter. In the left one, the Arduino-based embedded system. So in this case, I have some test points in order to minimize the requirement of handling manipulations, but for other ones, we require a special kind of measure to estimate the parameters of the system. So in the most of the cases, I will use the test clips. First, we have test words provided by Multicom Pro, sorry. These are plugged in. We set the measure, in this case the resistance, to measure the reference resistor for the Ampmeter. And I will use a relative measure. This kind of measure reduces the influence of test wire resistance. So I'll join, wait a bit, and activate the relative function. So you can proceed to make the measure. Here we have a resistor of 21 ohms and 840 milliamps. So in other measures, I can remove these protections and use some crocodile clips in order to have the hands free, and using some reference test points in the board, I can plug to make the required measurements. Other kind of measures is made with the accessories included, like this one. For measure the beta of a transistor, we need to remove the test clips. And according to the manual, I must set the HFE function, plug the accessory, and bring some devices under test, in this case of NPN or PNP transistors, and measure the constant, in this case the beta. So remember that this feature, this characteristic, is dependent of the temperature. So you could make your uh, test, take other devices, have a better characteristic, and if you want, you could develop a small temperature sensor. So this feature uh, has a high dependence with the temperature. You will bring a intelligent sensor based on this phenomena. So for other measures, we need to remove the accessory, set our clocks, and proceed to do it. So let's make this with the embedded system in operating mode. For this experiment, I prefer use the hands-free approach with our copyright clips to make the measures. In this case, I am using the frequency and duty cycle measuring. To improve this approach, I am using the USB cable included in the package to interchange information shown in the corner upper right. In this case, using the MP Lab data visualizer to manage the information interchange. I'll send 5 character to see which is the effect. In this case, we can see a better brightness in the LED. In addition, we can see a 49 duty cycle. In the other side, we can see the measure of the current using a reference resistor. In this case, we have a small variation, but we can see that the current through the LED is about 6 milliamps, 6.4 milliamps, 6.3 milliamps, and so on. But we can see other kind of features. For example, Arduino manage 16 MHz clock frequency. This brings a PWM frequency about the 62 kilohertz. So this could be visualized hanging the function, in this case hertz percentage pattern, and we can see that frequency. If we made some changes in the registers of the microcontroller, we can achieve other frequencies for other kinds of loads. For this case, we can manage the duty cycle from 0 to 9. In this case, we can achieve the minimum and the maximum coverage available in the LED. This is controlled by the PWM and the transistor with a base resistor calculated. Remember some calculations about how can stimulate the transistor. In the other hand, we can see the voltage in our ADC. Okay. According to Fourier theory, the duty cycle brings the average voltage. For a low duty cycle, we have a low voltage. For a high duty cycle, we have a huge voltage. In this case, the maximum allowed in our loop. So we can vary this brightness, the voltage in accordance to it, and we can measure that features. For this time is all. If you have any question or any recommendation about this, please don't hesitate to contact me to provide more information about this kind of practices.